Alrighty, so we're going to find the empirical formula for propane, which is a hydrocarbon. We've talked about hydrocarbons before. They're composed of carbon and hydrogen. Sometimes they will also include other elements like oxygen, nitrogen, phosphorus, chlorine. In this case, propane is just carbon and hydrogen. We have its percent composition, and we know that propane is 81.82% carbon, and we know that it is 18.18. That looks like a time. I'm so sorry. 18.18% hydrogen. Okay. Remember, since they don't give me a sample size, I can assume that my sample of propane is 100 grams, which is going to make these percentage signs just grams. So that makes it way simpler. So now 81.82 grams of carbon in my sample and 18.18 grams of hydrogen in my sample. And this marker is going out. Okay. We're going to start with green now. Alright, so for carbon, I can get out of grams of carbon and into moles by dividing by grams and multiplying by moles. And I know that the relationship between grams and moles, or mass and moles, is going to be molar mass, which means that 1 mole of carbon is going to weigh a certain number of grams. Remember to get that information from your periodic table. Okay, so carbon weighs 12.01 grams for 1 mole. That'll cancel out my grams of carbon and leave me moles of carbon. Okay, I'm going to go ahead and set this up for hydrogen as well. Alright, so 1 mole of hydrogen is going to weigh 1.01 grams. My grams of hydrogen cancel and I'm left in moles of hydrogen. Okay, at this point I will keep everything to 4 decimal places. Okay. So I'm going to take 81.82 and divide it by 12.01. And record this as 6.8127 moles of carbon. Alright, and for the moles of hydrogen, I'm going to take 18.18, and this should be alright on the dot. 18. Just to keep it 4 decimal places, let's go ahead and do that. Alright, at this point, to find the ratio of carbon to hydrogen, so these are the number of moles I have, what I can do is divide by the least number of moles, which is going to be from carbon. Okay, this is going to equal 1 mole of carbon, so 1 carbon for every how many hydrogens now? To do that, we're going to take 18 and divide it by 6.8127. Okay, and this is going to give me 2.64 moles of hydrogen. Okay, this is roughly 2 2/3, so anytime that we get a number that's like 0.33 something or 0.66 something or really, really close, that tells me I need to multiply everything by 3 to get rid of the thirds. So I'm going to multiply this by 3, I'm going to multiply that by 3. This is going to give me, let's go ahead and do this in another color for our answer. So 3 carbons for every, let's go ahead and multiply this by 3. See how that's much closer to 8? So 3 carbons for every 8 hydrogens. So for propane, my formula, my empirical formula, should be C3H8. And I know that propane is C3H8, so I can go ahead and confirm that that is the correct empirical formula. Ta-da!